Hi everyone, we are back and we are going to do our chi-squared goodness of fit contingency test. So we have a data set with nuclear explosions. I want to investigate if basically the type, specifically airdrop, shaft, tunnel, atmosphere, and country, USA, USSR, are correlated in terms of total upper yield of the explosions. So we're going to create a contingency table and we're going to perform a chi-squared test to determine whether the variables, so basically type and country, are correlated. And we're going to calculate a p-value. We're going to create two box plots showing the distributions of the upper yield explosions for each type, for each country. So let's go ahead and grab the contingency table first. So let's go ahead. We're going to go. I'm going to load up our packages. I am going to set our working directory as usual in this downloads folder where the data is. And our data is going to be this nuclear explosion data. And we can see here, and we have country here, and then we also have our, let's see, where's our type? Not source. Type is here, and then we also have basically the upper yield here. So what we're going to do is we're going to filter out, and we're going to grab kind of the raw data that we want. So we're going to filter out, and we are going to first grab everything that has airdrop, shaft, tunnel, atmosphere. Then we're going to grab, after we have all those, only the ones from USA and USSR. We're going to select type, country, and yield in terms of our data. So the filtered nuclear data. And you can see it's nice and pretty here. Always good to double check the data. Then we're going to go ahead and grab essentially our values. And because we want the, basically, the total upper yield of the explosions, meaning I'm going to have to grab the type for airdrop and for USA, and I'm going to have to select the upper yield, then I'm going to have to sum them. So I'm going to get a value. And you can see here the value is, this is the total or the sum of that upper yield explosion. I'm going to do the same thing for airdrop for USSR, and then airdrop for, not for France. Uh-oh. We need to change this. We can actually make this a lot easier, because we need to just do this for USA, USSR, USA, USSR, and then let's get rid of this. USA, USSR for atmosphere. Here we go. Great. So we've done USA, USSR here for airdrop. Now we can do shaft, and we can see those values. There we go. Nice. Now I'm going to basically create a contingency table. So I'm going to put and pull out my value for airdrop USA, shaft, tunnel, atmosphere, and the same thing for USSR. So I'm going to set up my matrix here. I'm going to say we're going to have 4 columns. They're going to have those column names, and by row will be true. So we can kind of just use that right here. So we'll grab that, column names, column rows. This is an important step. We need to visualize our data. So we're saying USA airdrop needs to be 3865. Yep, that looks to be correct. And let's pick one other random. Let's say USSR tunnel. So let's do tunnel USSR 35140. Yep, so we've set up our data correctly. Now we can do our chi-square test. So that is basically reject, meaning that the variables are indeed dependent. So we see we've calculated p-value. So we also want the box plot. So just for the USA, and we want to look at the type. So we can filter out here, and we can see, we kind of see the same trend, right? Let's go back here. High, then low, right? High, then low. So there looks to be dependent if we look at this. But that's the nice part about the contingency table test. So that's it. We'll see you in the next video. Thanks. Bye. And here we can look one more quick look at this code. Might be helpful. Thanks.